Hi everyone, my name is Sudhindra Rao. Welcome to this Introduction to Machine Learning session. This is the first presentation in the series in which I'll be explaining a little bit about how machine learning works and what kind of algorithms are there. A little bit about me. My name is Sudhindra Rao. I by training I'm a bioinformatics person. My training was in bioinformatics, and then I started working for a company called Monsanto Research Center. That is where I started working on a lot of these algorithms, machine learning algorithms. Um, I worked with them as a bioinformatics scientist for close to 5 years, and after that I left and I joined Accenture, which was in Mumbai. Again, in Accenture, I was working as an analytics and modeling specialist. I worked with them for close to 3 years, where again my core responsibility was to build machine learning algorithms, basically all kind of data analysis. And then I again came back to Monsanto, but to a different team. Uh, and I was working as a data scientist for close to 3 years. And in the year 2016 and or 2017, I started this company called Dataload Labs with two of my other friends, and I've been working with Dataload Labs since then. Okay, and overall I have around 12 years of experience. I do like part of this Dataload Labs, I do a lot of trainings, project implementations, and things like that. Okay, so little I just want to give you a little bit of idea about the company also. Okay, the company is called Dataload Labs Private Limited. It's a Bangalore based company. As I said, we started this in 2016. The whole idea was to like bridge the gap between the supply and demand of data scientists. Okay, so what we were trying to do was we were trying to train people in data science, uh, get them up to speed, make them job ready with the techniques or the kind of technology that companies look for, and use those talent pool or use that talent pool to execute projects that we get from our clients. Okay, so part of Dataload Labs, we do a lot of different kind of services. We do consulting service where we actually talk to the client to understand what kind of data sets they have, what kind of analysis they need, what kind of workflows that they're currently working with, and we help them actually integrate AI pieces into these existing workflows. Okay. Uh, a lot of times companies generate a lot of data, a huge amount of data, but they'll not have much idea about how to actually make use of this data sets and like bring much more efficiency into their existing workflows. Okay, so as part of Dataload Labs consulting service, we do this. Okay, we talk to those people. We try to brainstorm with them as to like what kind of models can be built, what kind of data analysis can be done with their data sets. Okay, and the second type of service that we offer is development service, where actually we build machine learning and deep learning based algorithms for the clients. I mean, they'll have a data set, they know exactly what they want to predict, and we just take the implementation part and execute it on our company and deliver it to the client. Okay, and the third kind of service, as I said, is learning and development service, where we actually take a lot of training programs. We do corporate trainings, we do university programs, we do student workshops, we do faculty development programs. We also have our own weekend batches that we run in our facility, and apart from that we also do the student workshops. Okay, so these are some of the services that we offer as part of Dataload Labs. Now coming directly into the technical part of the discussion. Um, so this series is all about artificial intelligence. I would like to, like, before we go into anything like any technical piece, I would like to actually talk about what exactly is artificial intelligence. Okay, I'm sure many of you are already aware of artificial intelligence, data science, machine learning, all these terminologies, but still, like, there are a lot of people out there who are like trying to figure out how exactly these are all interlinked. Okay, so first thing that we will be looking at is called artificial intelligence. So what is artificial intelligence? Very simple, like as the name suggests, artificial intelligence is a system that is artificially intelligent, right? So it's a very straightforward definition, but to give you some more examples as to like what exactly is artificial intelligence, for example, you would have seen these toy cars, right? So you have these toy cars that move on itself, move by itself, and as soon as it sees a wall, it just changes the direction and like takes a turn and goes in another direction, right? So it knows that okay, there is an obstacle, so I can't hit the obstacle, so I have to change the direction, right? This is nothing but the car is actually smart, right? Or it is intelligent, right? And how did we give this artificial intelligence to the toy car? We actually do that using something called as sensors, right? You would have something called as proximity sensors. So this toy cars will be fit with those sensors. It sees that okay, the obstacle or the next object is this much distance from the car. Okay, so if the value of that distance is less than a particular threshold, it changes the direction. Okay, so very simple example. Okay, or to give you a much more realistic example, you would have seen these vacuum cleaners, right? You can just turn it on and leave it on the floor. It keeps crawling across your room, cleans it, and actually it does the same thing, right? As soon as it's about to hit some obstacle, it changes the direction, goes somewhere else and cleans the room, and it keeps doing this throughout the day so that everything is clean, right? So again, this is an artificial intelligence system where you're using some kind of a sensor to make the system artificially intelligent. Okay, another example could be like artificially intelligent devices, right? For example, you have a AC, okay, air conditioning system that turns on automatically as soon as you enter the room, right? Again, this also works based on some kind of a sensor or something like it's linked to your cell phone. So as soon as your cell phone is nearby your AC system, it just knows that okay, the person has entered the room and it just turns it on. Okay, so again, this is again a smart device, right? Or smart system, or I would say intelligent system, but this is artificially intelligent by using these sensors, right? Now coming to some more little more complicated examples. For example, you have artificial intelligence system that actually predicts what will be temperature in Bangalore tomorrow, right? So in this case, what happens, the system is intelligent. It actually looks at historical data and tries to predict what will happen in the what will happen to the temperature in Bangalore tomorrow, right? Another example could be like an artificial intelligence system that predicts if a particular credit card transaction is fraud or not, right? So you would have used credit cards, right? So sometimes you would have got a call from the bank saying, okay, we see some kind of a possible fraud that is happening on your card. Did you really do this transaction, right? You would, all of you, many of you would have got this call from your customer care or your credit card customer care, right? So how do they know that if a particular transaction is fraud or not? Basically what they do is they take your historical data set, like let's say you're using your credit card from last 5 years. Okay, so using that 5 years data, the system or this artificial AI system, it tries to understand the pattern associated with your spendings. Lot of things, okay, not just the amount. It takes a look at a lot of different things like amount, time at which it was swiped, uh, then location in which it was swiped, what kind of end software was used, like did you do it online or did you actually swipe the card. Okay, looking at all these things, it will actually do something called as pattern mining, So what it will do is, okay, historically, let's say you have done 1 million or let's say 1000 transactions, right? So out of those 1000 transactions, let's say 50 of them were actually fraud. Okay, you didn't do it, someone else did it. Okay, so what it will do is it will actually mine the pattern. So whenever a new transaction happens on your credit card, it tries to match it with fraud transaction versus genuine transactions. Okay, if it is close to your genuine transaction, the transaction goes through, but if it is similar to your fraud transaction, it actually raises a red flag and you would get a call from your customer care. Okay, so this is another example of AI system where a credit card transaction is flagged as fraud or genuine. Okay, now talking about little more complicated examples, you would have all seen or used these home automation systems, right? For example, Alexa, Amazon's Alexa. You can actually give voice commands to this Alexa, and it does a lot of different things, starting from turning on the appliances to playing your favorite music, calling someone using your phone, a lot of different things, right? So here also what happens, it's a very extremely intelligent system. Like the previous examples, they were actually less intelligent, but when you talk about Alexa, it's a little more intelligent than the other systems, right? And how exactly it works, it takes your voice as input, it tries to understand what exactly you're trying to say or what is your intent, and using that intent it tries to predict what exactly the action it has to do. Okay, so that is how Alexa works. Another example could be like, you would have seen this, I'm not sure if you have seen, but you would have definitely read in news articles saying these artificially intelligent systems are able to predict some kind of diseases using your MRI images, right? Or maybe chest X-ray images, right? So this is again, what it does is it takes your image of your chest X-ray or let's say MRI, and what it does is it tries to understand those pixel values. Like basically your MRI or chest X-ray is nothing but grayscale image, right? It tries to understand how that grayscale image is drawn or how exactly it is on that MRI image, and based on that it tries to predict if you get a particular disease or not. For example, recently you would have seen, right? Using chest X-ray, a lot of people are trying to predict if a person gets COVID-19 or not, right? So this is again a very complicated artificial intelligence system. Basically it's doing the job of a doctor, right? So that is another example. Okay, another very like happening example is your self-driving cars. I'm sure everybody would have heard about self-driving cars, although it's little early to say anything about self-driving cars, but a lot of research is happening in self-driving cars. There are a lot of like production ready cars, but they're like waiting for a few other things like ethical reasons and things like that. Okay, but what they do is they actually mimic the job of a driver, right? So basically what it does is takes a look at your image. Okay, basically it has a head mounted camera that takes 360-degree surrounding videos, and using that 360-degree surrounding video, it tries to take a decision as to like, okay, should I go like this or should I turn the steering wheel by what angle, should I apply brake, is there an obstacle, is the road steep so that I have to increase my acceleration. All these decisions are being taken by your self-driving cars. Okay, so again very complicated examples. Okay, now if you actually see this all the examples, what I've done is uh, I've just put them in increasing order of their complexity. Okay, so now which among all these examples is artificial intelligence? All of them, right? Because every system here is actually intelligent. It does something uh, where it does an intelligent job, right? Or a smart thing, right? So all these examples are artificial intelligence. Then you would have heard about a term called machine learning, right? What exactly is machine learning? Machine learning is nothing but a subset of artificial intelligence where you need some kind of a data set to make the system artificially intelligent. Okay, if you actually see, all these examples are AI systems, because everything is artificially intelligent. But if you take a look at the first two, they don't really need a data set to make the system artificially intelligent, right? So those are not part of machine learning, but rest everything requires some kind of a data set. So whenever you have an artificial intelligence system that uses some kind of a data set, it's called as machine learning. Okay, then comes another subset of machine learning called as deep learning, where you'll be able to solve extremely complex problems using a special algorithm called as neural networks. Okay, basically you have something called as deep neural networks. We'll try to cover how exactly neural network works in the last session, fifth day session. But you have a subset of machine learning called as deep learning, where you use this neural networks to do extremely complicated jobs. Okay, just to put this entire thing into a Venn diagram, this is how it looks like. Okay, so you have something called as artificial intelligence, which is a very broad term. You have your everything, like every single system that is artificially intelligent falls into this artificial intelligence bucket. Okay, and if you see, machine learning is actually a subset of artificial intelligence, where the system is artificially intelligent using some kind of a data set. Okay, data set and some algorithms. Okay, and then comes deep learning, which is again subset of machine learning, which makes some of the extremely complicated problems possible. The solution to some of the extremely complicated problems possible by using a special algorithm called as neural networks. Okay. So machine learning and deep learning are the techniques that uses some kind of a data set to make the system artificially intelligent. Okay. So when we talk about data, you would have also heard of another term called as data analysis. So what exactly is data analysis? Again, data analysis, just like artificial intelligence, is a very broad term. So any technique where you take a data set, analyze it, and try to find out more insights from the data, it's called as data analysis. Okay, so we actually have different types of data analysis steps, or I would say the process. The first step that we usually follow is called as descriptive analysis, or descriptive statistics, or descriptive analytics. So what exactly happens here is, we take our data set and we try to answer the question, what has happened. Okay, so we take the data, we try to find out what exactly has happened till now. Okay, so how do we do that? We have different techniques to do that. We use visualizations, we use simple summary statistics, we use trend analysis and things like that to find out the answer for this. Okay, so it's one of the least complex step in data analysis, and the value it brings to the table is also less compared to the other ones. Okay, the second type of analysis that we do is called as diagnostic analysis, where we try to take the answers from descriptive analytics and try to find out more about that. Okay, it's actually one step ahead of descriptive analysis. In diagnostic analysis, you try to answer the question why it has happened. Okay, in descriptive analysis, you try to answer what has happened. In diagnostic analysis, you try to find out answer for that, like, okay, if let's say we see this is the trend of sales. Okay, that is done in descriptive analysis. In diagnostic analysis, you try to answer why do we see this kind of trend in our data set. Okay, that is your diagnostic analysis. And then comes the next step, which is called as predictive analysis. And predictive analysis is where you try to answer other questions like, what, okay, we have already answered what has happened, why it has happened, right? And in predictive analysis, what we do is we try to predict what is going to happen in the future, or what is likely to happen. Okay, so your machine learning is actually part of this. Okay, like predictive analytics is done using your machine learning algorithms and deep learning algorithms. And finally, the last step in any data analysis is called as prescriptive analytics. Basically, it's again one step ahead of predictive analysis. In predictive analysis, you try to answer what is likely to happen, and prescriptive analysis is where you try to answer, okay, if you do this, this is what is going to happen, or what action should be taken. Like it just prescribes the right path for any business. Okay, so if you actually see the complexity of these different types of data analysis, the complexity increases here. Descriptive analytics is simple, or exploratory data analysis is simple, but prescriptive analytics is the most complex one. And at the same time, since it is more complex, the value it brings to the business, or the on the table, is also more. Okay. uh, then we talked about predictive analytics done using machine learning and deep learning, right? So we will talk about some of the algorithms that we have in machine learning and deep learning. The first algorithm that we will be looking at is called regression. In tomorrow's session we'll be talking about regression in detail. So in regression, what we do is, let's say we have a data set that looks like this. We have, let's say, price of different houses, and at the same time we also have the area information. Okay, for example, if you see this house, it's priced at around $300,000, and it's around 500 square foot area. Okay, and this house here is actually around again somewhere around $300,000, and the area is around 700 square feet. Okay, and if you see this house here, it's around 2,000 square feet, and the price is around $850,000. Okay, so this is a dummy data set with some very few data points, but in your actual problem you'll have like thousands of data points. Okay, so okay, so let's say we have a data set like this, uh, and if we try to answer questions like, okay, what might be the price of a house which is 1,300 square foot area, right? So what you do is 1,300 is here, right? So okay, first thing is, before anything, we actually come up with some kind of a pattern associated with this data, or something like a trend. Okay, so in this case what we do is, we actually see that as the area increases, your price of the house also increases. So we try to capture the trend using some kind of a line or a curve. Okay, and we use that curve to answer a lot of our questions, like what might be the price of a house with 1,300 square foot area, right? So if you see 1,300 square foot is somewhere here, and what happens is you just extrapolate it on the line, and just extrapolate it on the y-axis, and you get your price value. Okay, so this is called as regression algorithm. We'll be looking at this algorithm in detail in tomorrow's session, but in this case, if you see, actually what are we trying to predict? We are trying to predict price of the house, which is actually a numeric value. So whenever you have a numeric value as your target, or you're trying to predict a numeric value as your prediction, you will be using an algorithm called as regression. Okay, so in simple words, it's actually a predictive technique or machine learning technique for predicting continuous value targets. uh, as I said, it's nothing but your curve fitting. If you actually see this line, it's nothing but a straight line, right? It has an equation of y is equal to mx plus c. So this is the equation that we try to come up with. Okay, so given the values of target and feature, we try to come up with the values for m and c. Okay, so that is what happens in regression. There are different types of regression. You have simple linear regression, you have multiple linear regression, you have polynomial regression. Many other regression types are also there. And basically, whenever you have a problem where you're trying to predict a continuous value target, you'll be using regression algorithm. Okay, some examples can be something like this. You can actually predict house price based on area of the house, as we saw in the earlier example. Or let's say, okay, that example had only one feature, which is predicting the house price based only on the area of the house. But you can actually build a much more complex algorithm, where you're trying to predict house price based on many other features. Okay, like area of the house, how many rooms are there, what is the location of the house, what is the crime rate of that location, how far is the nearest school, how far is the nearest shopping mall, how far is the nearest hospital, is the house east facing, west facing. All these things can be used to build used to predict the house price, and you'll be using an algorithm called as regression to do the same thing. Okay, another example could be like predict mileage of the vehicle based on, let's say, your engine displacement. Okay, you can actually think about lot many other examples for regression algorithms. uh, it's one of the simplest, oldest, and most powerful algorithm in machine learning. Okay. uh, okay, so that is the first set of algorithms, or first broad bucket of algorithm. And the second type of algorithm that we use is to solve or is to predict not continuous value target but discrete value target. Okay, in the previous example we were trying to predict house price, right? House price can be anything. It can be 10, 20, 30, 40, 50, 100, 200, anything, right? But sometimes we will be predicting uh, values that can take only predefined number of outputs. For example, uh, based on the marks obtained in first exam and marks obtained in the second exam, we want to predict if a particular student will be admitted to some program or not, right? So if you see, we are trying to predict if the student is admitted or not, right? It can't take any number of values. It can take only two values, which is admitted or not admitted, right? uh, in contrast to the other example that we saw, in this case we can take only predefined number of outputs. Okay, so in such a case what we do is we use an algorithm called as classification. It's actually a technique for predicting discrete targets. Regression is for continuous target, classification is for discrete targets. And in case of regression, what we do is we come up with a line or a plane or a hyperplane to predict the trend. In case of classification also we do the same thing. We come up with a decision boundary, we come up with a line or a plane or a hyperplane. But the idea of this plane or a hyperplane is slightly different. In case of regression, we are trying to come up with a line that best represents all the points in your data set, whereas in classification you are trying to come up with a line that best separates the classes into two different classes. Okay, for example, in this case if you see, we have plotted marks obtained in the first exam versus marks obtained in the second exam of the student. And if you see, all these green dots that you see, for example here, okay, and this student has obtained 100 marks in the first exam, but in the second exam, but in the first exam he has only got 35. Okay, similarly if you see this guy here, this person here, he has scored 40 in the second exam, but in the first exam he has scored 95. Okay, so or 98 or whatever. Okay, so similarly we have lot of information about lot of students, and what we want to do here is we want to come with a line that separates these people from these people, okay, or people who are admitted from people who are not admitted. Okay, and this line here is called as decision boundary. We'll talk about it in more detail when we discuss about classification algorithms. Again, there are a lot of different algorithms out there for classification. Different algorithms have their own way of coming up with these decision boundaries. Okay, one of the simplest one is logistic regression, but apart from logistic regression you also have support vector machines, decision trees, random forest, neural networks, and lot many other algorithms. Okay, in the future sessions I'll be talking little more about support vector machines and decision trees, and probably artificial neural networks. Okay. uh, okay, so some examples for classification could be something like, you would have used email boxes, right? You see that there is a spam email filter. So whenever a new email comes in, what happens is it actually goes through this classification model. It actually looks at your content of your email, like what different keywords are there, who was it sent from, who did send this email, what kind of keywords are there in the email, how many people it was sent to, what is the domain of the sender. Using all this information, it actually tries to predict if a particular transaction or a particular email is spam or not. Okay, just like how earlier we talked about credit card transaction being fraud or not, right? It's exactly similar, but the feature that is used to say if a email is spam or not is different from fraud or not in credit card example. Okay, another example could be like, using your various test results you'll be able to predict well in advance if a person has breast cancer or not. Okay, or if a particular tumor is malignant or benign. Okay, or another example could be like image example. uh, as soon as you upload image to Facebook, it actually puts a square box around your face, right? How does it know that that is a face? It's actually a classification model. So this classification model actually takes the pixel intensity in that region and tries to predict if this pixel intensity matches with a phase or not. Okay, so these are some of the examples of classification model, okay, which is the second broad category of algorithms. Okay, both regression and classification is actually called as supervised learning, because we actually know the output well in advance. Okay, and when we train the model, we actually use that information to train the model. Okay, then comes an unsupervised algorithm, where we have data points, and what we can do, we don't have any outputs associated with these inputs or these data points. And what we want to do here is we just want to group them into different groups. Okay, and this is actually called as clustering. It's actually called unsupervised learning. It's a part of unsupervised learning algorithms, because we are not supervising the algorithm as to like what exactly to learn. Okay, so basically clustering is a technique for predicting groups. Okay, if it is classification, it is technique for predicting exact labels. There we will be predicting labels like if the person is admitted or not admitted, right? These are labels. Whereas in case of clustering, you don't have that final information. What you do is you try to put data points together based on their similarity or dissimilarity. Okay, again, in clustering also you have a lot of different algorithms. You have hierarchical clustering, you have k-means clustering, you have db scan, spectral clustering. A lot of different algorithms are there, which can be used for this unsupervised learning method. Okay, some examples: you have used Google News, right? On the left side you see that categories, right? How exactly these categories are actually created for each news article. It's not that someone sitting there manually and trying to read every single news article and tagging it with the news, sorry, the term. Instead, what happens is we actually take the entire corpus of news article. Sorry, we take the entire corpus of news articles. We try to see which articles have similar words, and based on that, we try to put them into different groups. And once we have these different groups, we try to look at each group and try to put them into appropriate categories. Okay, or another very good use of clustering algorithm is in your smart cities. So we have something called as optimum allocation of few things, right? Like for example, in smart cities, what happens, everything is planned, so your amenities are placed appropriately in the optimum placement, or they are placed in the optimum location, so that it caters to everyone. It's not biased for one locality and not unbiased for another locality, not like that. It will be placed exactly at the center of the entire thing. And how exactly it works, it's people use clustering algorithm to do these kind of things. Okay, and another example could be like it's also used in a lot of image segmentation. Image segmentation is where you take an image and try to come up with different groups of or different regions in the image. Okay, especially useful in medical domain. You take an MRI of a brain, and you can actually run your clustering algorithm and try to find out different regions of the brain. Okay, otherwise what happens, if you just look at the raw MRI image, it will be a little difficult to identify what region is what. But using clustering, you can actually come up with those exact boundaries of these different regions. Okay, so for machine learning algorithms, your data set will look like this. You have features and you have your target. Basically, you have to provide features as well as target for supervised algorithms like classification and regression. And what it does is it actually tries to find out the pattern associated with these inputs with these outputs. Okay, so if you actually see this see this data set here that I'm showing on the screen, if you see, the salary value is actually continuous, and there are a lot of different parameters of a particular employee, of different employees. And what you can do is you can actually build a regression model here, that predicts salary based on all these different parameters. Okay, so this is a regression example, but instead of actually continuous salary values, if you're trying to put them into different groups like less than 50k salary or more than 50k salary, in such a case what happens, you can't use regression algorithm, instead you have to use classification algorithm. Okay, and sometimes you might not have that target column at all, and in such cases you have to come up with unsupervised algorithms like clustering algorithm. And basically what it does is it tries to group these different data points into different groups based on their similarity and dissimilarity. Okay, and finally, where do we use machine learning algorithms, or which companies, or what are some of the use cases of machine learning? uh, Machine learning is used by almost, like, a lot of companies use machine learning in almost everything that they do. For example, Google, starting from their search to their Google Maps, Google Photos, Google YouTube, whatever you talk about Google, they use the data for making the system smart. For example, as simple as, like, as you search in Google, as you type your first word, it tries to predict what could be the second word, right? So that is nothing but a machine learning algorithm where it tries to predict the second word based on your first word, or the third word based on your second word. Okay, so that is one thing. And if you actually have seen Google Photos, it actually puts your photos into different buckets or different groups automatically. Like, it puts them into selfies, it puts them into scenery photographs, puts them into food items, it puts them into like family photos and things like that. Whenever, if you have not checked it already, please go to Google Photos and check that for yourself. Okay, it also identifies different faces and tries to help you with easily finding all the photos of a particular face. Okay, then comes Facebook. Facebook also is like Google. It uses machine learning in almost everything that they do, starting from photos, groups, wherever even the Cambridge Analytica, where they were trying to target this election results, right? So all these uses machine learning algorithms. Okay, and then comes recommendation systems. Wherever you see recommendations, it's actually based on machine learning algorithms. For example, YouTube, as you watch some videos, if you keep watching some technical videos, it starts pushing more and more technical videos towards you. It actually changes that, okay, your likings have changed for technical videos, so these are all the videos that you should watch, right? Instead, if you watch movie trailers, like you have been watching a lot of movie trailers from last 10 days, it starts pushing all the new movie trailers towards you. Okay, not just YouTube, Amazon, Netflix, wherever you see this recommendation system, it uses some kind of a machine learning algorithm in the backend. Okay, and all your voice assistants like Siri, Cortana, Alexa, Google Assistant, everything, they also are built on machine learning and deep learning algorithms. It takes your voice frequency as input, and it tries to predict what exactly you're trying to convey, and using that information it tries to take appropriate actions. Okay, then we already talked about fraud, credit card fraud, or email spam. All those things are based on machine learning and deep learning algorithms. Okay, next big thing is your online gamings. uh, it could be as simple as a chess game, or as complex as your PUBG game or any other games. Everything uses machine learning in one or the other way. um, uh, the best example is some of these games where you have an infinite universe, right? You can keep walking on and on and on, and there is no end to the distance that you can walk. Okay, so it's not that some developer has sat and developed those environment in the background, like the hills, trees, and other things. So these are all machine learning created uh, environments that are widely used in these on these computer games, or let's say video games. Okay, then comes your IoT, Internet of Things. This is another place where we see a lot of machine learning use cases, not just machine learning, deep learning also. So all those systems are made smart by using some kind of a machine learning or deep learning algorithm. Okay. Then another very useful use case of machine learning is robotics. Okay, this is actually a robot called Sophia, which is actually a citizen of UAE. Sorry, it's Saudi Arabia's citizen, and this is when Sophia had come to IIT Mumbai. Okay, you should, if you have not already checked these videos of Sophia, you should definitely check it out on YouTube. The way it interacts with people, with the way it reads the facial expression of other people, it's pretty amazing. Okay, and how does that robot gets all this functionality using machine learning and deep learning algorithms. Okay, and finally, as I said, self-driving cars, one of the most awaited technology that we are waiting for, right? So what happens in this case is there is no driver seat. Okay, instead there is a head mount camera or some kind of a video capture device. Okay, and what it does is as it moves, it captures 360-degree surroundings. Okay, and that in the output of the 360-degree surrounding input is actually fed to a machine learning algorithm, which takes various decisions in a self-driving car as to like what speed the car has to go at, uh, where should we turn, what angle should we turn, should is there an obstacle, should we apply brake, is the signal right, red, green, orange. All these decisions are taken by a machine learning algorithm, and they use a technique called as reinforcement learning to do that. Okay, which is pretty new thing. It's slightly complicated than your deep learning algorithms also. Okay. uh, okay, so now to talk about regular programming versus AI programming, it's pretty simple. So in your regular programming, what happens, you have your input, you write your program logic in such a way that you get some output, right? So let's say you have a system, or let's say a, a program that takes user input and stores it into a database. So what you do is you have your input, which is user details, and you write a program that talks to the database and uploads it to database. You have to write this program logic, and finally you get your output, which is the data in your database, right? Whereas AI programming or machine learning is slightly different. In this case, what happens, you don't write the program yourself. The machine learning algorithm comes up with its own program, but what you have to do is you have to provide some kind of an input and output in certain format, so that the algorithm will try to find the pattern associated with input and output, and if there is a pattern associated with input and output, it tries to mine that pattern and stores it as a program. Okay, so this is the difference between your regular programming and AI programming. And it's not like at least at this point of time, AI programming is used only when there is a pattern associated with your data. If there is no pattern associated with your data, then your AI programming might not be really useful, or machine learning or any of the data analysis might not be really useful. Okay. So how does this machine learning process works? Okay, you have your input data. What happens is you do something called as pattern mining. Basically, in this step, what you do is you take your data, uh, like for example, if you're trying to build a model for fraud detection, right? So what happens is input data will have all the historical transactions. Okay, and along with the labels. Okay, historical transactions with labeled as, okay, these are fraud transactions, these are genuine transactions. Okay, so in pattern mining step, what we do is we take different features and we try to see if that actually has an impact on the output, and all this pattern will be mined and stored as a model. Okay, and this model will have information about, okay, how exactly does genuine transaction looks like, and how exactly does a fraud transaction looks like. Okay, so what happens when you have a new data, or let's say when you make a new credit card transaction, the transaction will be fed to this model. The features or the parameter values of the new transaction is matched with the mined pattern here with the model, and it sees that, okay, these particular this particular transaction details actually matches with the genuine transactions. Okay, it's very close to genuine transaction. So what happens, the transaction is not marked as fraud, it just goes through the process, or it just goes through. Okay, whereas in case, let's say there is a possible fraud, let's say you swipe your credit card in the midnight, like 3 o'clock, in some other country, for a huge amount, then what happens, these are all possible fraud transactions, right? Like amount, high amount, plus new location, plus uh, different time of the day you're swiping your card, so that matches with the fraud transaction. So what happens, the transaction is put on hold. You'll get a call from the bank asking if you have done the transaction, and if you have done the transaction, the transaction goes through, otherwise it will be like stopped. Okay, so that is how your machine learning project process works. This is similar for everything. Okay, your input data will have your historical data sets from which the pattern is mined, and that mined pattern will be stored as a model. And whenever you have a new data set or a new query, it is actually matched with the pattern stored in the model, and whatever it matches with, if it matches with let's say fraud, it's predicted as fraud. If it matches with the genuine transaction, it will be predicted as genuine transaction. Okay, so this is how machine learning process works. Okay, and one more thing I would like to talk about in this session is how exactly a machine learning project looks like. Okay, or what are the different steps involved in a machine learning project. Okay, it all starts with data collection, because we know that machine learning and deep learning projects, they need data to make the system artificially intelligent, right? So the first thing that we need is data, and data collection plays a very important role. So this data collection is the first step, because unless you have your data set, you can't do anything. So this is the first step where you actually collect the data set. Again, this data collection is in different is done in different ways. Okay, if your data sets are easy to collect, let's say you just have to scrape a website and get the data set, then the data scientist will be able to do this job. But let's say if it is something like house price prediction, right? The data scientist or the scientist will not be able to do this. It will be done from somewhere else, and the data scientist will be able to consume that data set from the third party. Okay, then comes a step called as data cleanup, where okay, we have a rule in machine learning. The rule is simple: we always consider the data is never clean. Okay, that is the rule. So what happens is, whenever we have a data set, we always look for errors in the data. The first step that we do is we try to take different rules and try to see if there are errors in your data set. For example, let's say you have age column in your data set. Okay, and you suddenly see the value as 400. Okay, that is definitely an error, because a person can't be 400 years old, right? So what you do is you either go back to your data collection step and see what exactly is the value. Okay, and correct it. Or sometimes what happens, you might not be able to do that because of various different reasons. In such a case, what happens, you either remove the data point from your analysis, or you can actually remove that particular value that you think is wrong, and you actually impute with different other values. Okay, so that is what happens in data cleanup step. As I said, data is never clean, so you always do this data cleanup step after you get your data, so that all the errors, discrepancies, everything in the data is removed. Okay, and the next step is data preparation. And as the name suggests, this is where we prepare the data for machine learning algorithms. Okay, so this involves a lot of different things, like uh, as I said, there will be some missing values, right? Let's say age column, somebody didn't actually give out their age. Okay, and as a result, what happens in our data set, the value is blank. Okay, in such a case, what happens, we can't directly use that in our algorithm, because algorithm does not know how to work with missing values. So we may have to do something called as missing value imputation. Okay, there are different techniques in which we can do missing value imputations, and that is done in this data preparation step. Okay, not just missing value imputation, we do a lot of other things like data normalization, missing value imputation, feature transformation. Sometimes what happens, you have a feature, let's say area. Okay, maybe area is not a good feature, instead you have to use area square. All those kind of transformation needs to be done in data preparation steps. Okay, so after everything is done in data preparation step, another very important thing in data preparation step is your outlier detection. Outliers are those data points which are not following the trend. Okay, and if you use it in your data set or in your analysis, you might get misleading results. So as a result, what we do is we have to remove these outliers from our data set, and that is done in this data preparation step. Okay, once your data is prepared, then comes another broad step called as model planning. It's done through visualizations, your statistics, various different things. Okay, basically this is where we actually plan our model. Like, okay, these are the features that needs to be used, these are the features that does not make sense, so needs to be removed. These features are really important based on some statistical measure, but these features are not making any sense, they are not statistically significant. All these kind of things are done in model planning. You even select your algorithm, what algorithm we should use, what kind of parameters we have to use for the model. All those things are decided in this model planning step. Okay, once that is done, then comes your model building, where you actually try out your model, you build your model and get your output. Okay, or mine those patterns. Okay, and again, in model building step also you have other steps which is called as model tuning. Sometimes what happens, you might build a model in the first step, whatever model that you get might not really give you good results. So what you have to do is, model will have something called as hyperparameters. You have to tune them to get appropriate results for your data set. Okay, and these hyperparameters will be different for different data sets. So in model building step itself, what you do is you actually do all those hyperparameter tuning, you make the model better, and finally you get your model. Okay, once you build your model, that is not the end of it. You can't say, okay, my model is done, I'll go ahead and start using it. No, you have to do something called as validation, where you actually take your model and try to see if the output of your model is making sense or not. Okay, and how do you do that? For that, we actually keep a small piece of data aside. Okay, when we are trying to build our model, we actually keep a small data set, a small piece of the data, let's say 20% of our data set aside. So once our model is built, what we do is we actually push those 20% of data through the model, and we ask the model to predict what will be the output for these 20% of the data. Okay, and once we get the output from our model, we also have the actual output of our actual output for this 20% of the data. We actually compare this actual versus predicted, and if they're matching, that means our model is doing a good job. If they're not matching, then our model is not doing a good job. So what happens is, if your validation step fails, you again go back to any of these steps. Okay, so your this process is cyclical. So once your model validation is succeeded, or your model validates, then you can go ahead and productize it into a product. Okay, like in case of simple machine learning algorithm like spam detection, the algorithm is just a software. But in case of, let's say, self driving car, your algorithm is not just a software, it's actually software implemented in an embedded system. Okay, so productization step is also different for different projects, and sometimes it is done by the data science or the person who is involved in machine learning project, but sometimes it is done by a completely different team. Okay, but this is in broad, this is these are the 7 steps that we follow in machine learning project. uh, as I said, this data cleanup to validation step is cyclical. You can actually go back and forth. Actually, basically, like, your data science project always works in multiple iterations. So what I mean by that is, you build a model, you get an output. Sometimes it's good, sometimes what happens, the output is not really good. So you go back and change few things, you make the model better. and you keep doing that in multiple iterations until you get a satisfactory model. Okay, so that is how machine learning project works. Okay, and yeah, I mean, just to give some more examples of these algorithms, the three broad category of algorithms. Regression is used a lot in weather prediction, temperature, rainfall, humidity, wind. All those predictions are done using regression. Basically what they do is they, for example, temperature or rainfall is predicted based on a lot of different things, like what is the temperature, what is the humidity, what is the wind, how exactly it was 2 days back, 3 days back, 4 days back, all those things. Another place where we use regression a lot is sports betting. uh, Sports analytics or sports betting is a place where regression models are used a lot. Okay, another thing is your stock market predictions. Okay, again, price prediction, indicator prediction, all those things can be done using regression models. And finally, your self-driving cars also. Okay, it's like there are a lot of different modules in self-driving cars which can be called as regression models. For example, what speed the car should go at. Okay, or what should be the steering wheel angle, or what should be the acceleration. Okay, these are all the questions that can be answered using regression problems, and they'll use reinforcement learning to solve these regression problems. Okay, and coming to classification, again, all these face filters like Snapchat, I don't know, a lot of other things where you have this face filters, right? So it actually uses classification algorithm. It identifies where exactly is the eyebrows, where exactly is your cheek, where exactly is your chin, where exactly is your lips, nose, everything, and uses that information to place these filters. Okay, and there is one very good application called TapTapSee, which you can take any picture of anything and it actually gives you a description of what exactly it is seeing. Okay, it was actually an app that was developed for visually impaired people. They can actually direct their smartphone at anything and they'll get to see or get to hear what exactly the app is seeing. Okay, um, disease prediction is another place where classification models are really good. The recent example could be COVID, right? A lot of people are trying to predict COVID using chest x-rays, MRIs, this, that, 100 different things. Okay, then stock market prediction is another place where classification can be used. You can actually predict if the stock is going up, down, neutral, all those things can be predicted. Okay, and just like that, even your self-driving car will also have a lot of classification modules where you're trying to predict a lot of different things using which are like discrete in nature. For example, is the signal light red, green, or orange? Okay, or is there an obstacle? Should I apply brake? Is there a vehicle in the front? Is there a road sign? If the road sign is there, what exactly it is saying? All these things are classification models that are built in your self-driving cars. Okay, and finally clustering, as I said, Google News, your shopping sites also, like as soon as for example Mintra, as soon as you order a t-shirt, or let's say check a t-shirt, it will also show similar items, right? How exactly it does, it's basically based on clustering algorithms. So what it does is it actually takes the entire items in the store and tries to build a clustering model. Basically clustering will give you which items are similar to each other, right? So they'll come up with different clusters, and as soon as you order or check an item from a particular cluster, it tries to show all the other items in that cluster because they're all very similar to your item. Okay, so that is one thing. Then you can also, as I said, you can also use it for image segmentation. Image segmentation is a very broad term in clustering where you can use your clustering algorithm for a lot of different things like edge detection, your object detection, your um, like medical image analysis. A lot of different things can be done using image segmentation. Okay, this is an example of brain tumor MRI, or let's say brain MRI with the clustering output. Okay, So all these things can be done using clustering. And yeah, that is the end of the session. uh, this is like just a very basic introduction to machine learning. In the coming sessions, I'll be talking a little more in depth about regression models, classification models, and artificial neural networks. Okay, thank you everyone. See you again tomorrow for regression session.